Now, before we get started writing our own C# applications, we have to take a moment to understand types. Types are a key concept for writing applications in C# and .NET. Now, the reason for this is that C# is very strict about having to define things before using them. And this is useful in areas like the compiler, where it will check your code and make sure that you are using types correctly, that you're spelling things correctly, that the right type of data is being passed between your objects. All of these things help you write more scalable and well-defined code. And types can also be thought of as building blocks. You can take smaller types and arrange them in different ways to create new and interesting and more complex types. Now, to start with, we're going to talk about what are called the simple types in .NET. These are the basic building blocks from which all other types are created. Now, a type in C# defines the data and the behaviors of an object. And when we use the word object, we need to know two things. First, everything we work with is an object. Console is an object, every variable we create is an object. C# is an object-oriented language. Second, every object has at least one type. I say at least one because of something called polymorphism that we'll get into much later. The concept, though, is like taxonomy in the real world. Something can be a mammal, a canine, and more specifically, a dog. Similarly, we can define objects based on multiple types. So as an example, a bank account type might have some data, like information about the owner, the balance, the account number, and so forth. It might also contain code defining behaviors like depositing or withdrawing money. And because everything in C# is defined by at least one type, C#'s compiler will not let you do things that aren't defined by the type. As a silly example, our bank account type, you wouldn't be able to make it bark or eat. But what this does mean is that misspelling or improperly casing type members will cause errors. For our console class, this means that if you lowercase or capitalize letters incorrectly, C# will interpret them as distinct names and only the proper case version is correct. Because a type is a definition, this is what the error does not contain a definition for X actually means. Now, to help us visualize all of the simple types, I've created a chart here that breaks them down by category. In green, we have the names of the types, and in blue, we have the categories. As we can see, there aren't many of these to remember, and most of them are numeric. But let's go into each type in detail now. Bools, or more formally, Boolean types, can only have two values, true and false. And as we can see in this code snippet here, we declare two Boolean variables and assign the first one a value of true and the second a value of false. Notice that in the default Visual Studio color scheme, the words true and false are colored dark blue. This is because true and false are keywords in the C# language and have special meaning. Some languages also interpret other values like 0 as false and 1 as true, but C# is not one of these languages. You will always use the true and false keywords when you want to specifically assign a value of true or false. It's important to point out that Booleans are more often seen as the result of an expression statement, such as X is greater than Y, or is this account overdue? The car type represents a single character in C#, and it uses single quotes instead of double quotes like we saw with our Hello World string. And as we can see here, we can put one character in there like the character X, and we can also use something called an escape character, which is a front slash followed by a letter or character sequence that represents something more complicated like a tab character. And as I mentioned before, These built-in simple types are just building blocks. The string type is built from this type. A string is a collection of cars. Now, there are quite a few whole number types, but the difference between them is pretty simple. It has to do with the range of values that each number type supports. Developers can choose the values that fit their application. So here, I've ordered the types from smallest to largest in terms of how much computer memory they require. Because computers need to store each individual space in a number, the minus sign on a negative number takes up a space. And for this reason, the whole number types have two versions. One of them is signed, which means it supports negative numbers. And the other one is unsigned, which means it only supports the value 0 and positive numbers. So we start with the S byte, or signed byte. This is a signed version that goes from -128 to +127. Its partner, the byte, is unsigned and goes from 0 to 255. Notice how when we do not need space for the minus sign, we can store roughly 2 times the number. This is because of how bits, bytes, and binary work on a computer. Moving along, we have the short and unsigned short, which we can see expands the range of values that we can hold from -32,000 to 32,000 and 0 to 65,000 respectively. Next, we have the int, which is kind of the default whole number value that developers use when storing whole numbers. It's quite large, and it has signed and unsigned versions in the billions. And the long and ulong are really big. So here's the thing. In our examples and exercises, it's likely that we will just use the default int type for whole numbers because it's quick and easy. And for most small applications that run locally on your machine, that's just fine. We don't really worry about optimizing how much space we're using for the most part. We're talking about 32 bits when modern computers have gigabytes of memory. However, and this is really important, size matters when you build applications that need to perform at scale. You will want to use the appropriate size type for individual fields. For example, if you're storing a person's age, there's no reason to use anything except a byte, since the oldest person ever was like 125 years old. You also might ask, what do I mean by scale? Well, think about applications like Facebook and Twitter or banking websites for Fortune 500 banks. These types of applications have millions of concurrent users, so taking the time to really think about and save some memory space by using the appropriately sized type makes a difference. For an application that is only running for a small business, you can just use the default int, it's fine. You can always change it later if things scale up. Now, when we need decimal and scientific numbers, we can dip into the floating point types, of which there are 3 in the simple types. The float and double store very large numbers, as you can see by the exponential notation. But notice that the decimal type takes up more space in bytes, but represents a much smaller number. This is because of something called precision. The float and double are accurate enough, but aren't nearly as strict as the decimal when it comes to rounding and storing information out to many decimal places. For this reason, you should always use the decimal when you are doing anything with currency. Banks and government regulators, they tend to get a little upset when you lose pennies when doing long calculations that involve a lot of rounding. To be clear, float and double are accurate enough for most non-monetary situations. Nothing bad is going to happen if in a video game a calculation is 1/1,000,000th off, and as we can see in our table, the float and double take up less space, making them more efficient at scale. However, I recommend you get into the habit of using the decimal since it's so important for currency. It will be the default type I will use for floating point numbers in demos. Now that we've learned about primitive types, let's jump back over to our Hello World application and let's talk about comments and declaring variables. Now, code comments are ways that developers can leave messages and notes in their code files. Comment lines are not executed, and so they do not have any impact on the functionality of the program. Here's a few examples of times that developers use comments. First, to explain a particularly tricky bit of code. If you're doing something weird or complicated, it can be really helpful to other developers and even yourself if you come back much later to document what's going on in a comment. Second, you'll see comments used to call out documentation. For example, if we were writing some code to perform a scientific formula or something that we might want to reference with a link, we could put that link in the comment. And third, developers sometimes use comments as outlining tools when writing code. And this is something I highly recommend that beginners do. And we're going to demonstrate that in this video. Now, when it comes to actually writing a comment, there's 3 ways you can add comments. I'm only going to demonstrate 2 because the third one is more for documentation and generating documentation with tools and not so much code commenting. Now, the first type of comment is a single line comment. And if you put a double backslash, you'll see that the color of the font will change, and a double backslash makes a single line comment. Just like that. The second type of comment is a multiple line comment. Now, to do this, you'll do a /*. Again, it will turn green, and then you can type multiple lines of comments, and you end it with a //. This follows the theme of programming: what opens must be closed. Next, let's talk about variables. In programming, when we want to store data for later, then we need to use variables. There's 2 words I want you to remember when it comes to variables. Declaration is a program statement that creates and sets up a variable for use. Assignment is when we store data in a variable. Let's take a look at how to do this in our Hello World program. We'll also weave in some comments to describe what we're doing. Our goal is to make the program print out hello and our name. But to do that, we're going to have to perform a few steps. Computers can really only do one thing at a time. So let's use comments to outline what we're about to do. First, we're going to declare a string variable to store the name. Notice that I specifically say a string variable, and that's because a name is text. Remember what we discussed previously about C# being strict about knowing the types of data we are using. So whenever we declare a variable, we must also tell our program what kind of data type is going to be stored in it. Next, we need to ask the user for their name. In programming speak, we call this prompting. A prompt is a message that asks a user to do something. So we're going to prompt the user to enter their name. Next, we need to retrieve the name from the user. Now, this is a console application, so the user is going to type it on the keyboard. I'm going to show you which method on our console type does this. It's not enough just to invoke the method, though. We need to make sure to tell our program to assign the keyboard input to our variable. So as a comment, we're going to say get the name from the console and assign, store it to the variable. And then once we have the data, we can print it out to the console window using the WriteLine method that we already are familiar with. So let's go ahead and put in the comment for the final step. Write hello name to the console using WriteLine. At this point, I hope that you can see how I use the comments to outline what I'm about to do, and each individual step our program needs to take to be successful. Taking a larger task like ask a user for their name and say hello, and breaking it down to individual steps that a computer can do is called problem decomposition. And it's something that every programmer needs to learn to do. Early on, this is going to be difficult. It will take time and practice, but it will become second nature. This is a key part of being successful. you need to plan and write things down before you dive into code. Once you get a lot of experience, you'll be able to be less granular when you outline, but at least for the first 1,000 hours or so of practice, you should be very detailed and very deliberate about planning your code. Doing this is also good for getting help from other developers. If you show another developer your outline, they can better help you fill in any gaps or help you find a method or a type that you might need to be successful. Like right now, we don't know how to get the name from the console, but any C# developer that you showed that comment to would be able to tell you what you need to do, like I'm about to now. So let's start at the top. Declare a string variable to store the name. There are two things we need to do to create a variable. First, we need to tell C# what type of data will be stored in it. And second, we need to give the variable an identifier. Identifier is fancy talk for name or alias. Let's do this now. We're going to store their name. What's a good variable name to store a name? Let's just call it first name. Now, as we can see here, the format for creating a variable is to put the type string first, and then the identifier first name as second. Now, one thing about programming languages is that programmers have certain style formats that they follow for naming things. In C#, when you create a variable like this, we use something called camel casing, which means that the first letter is lowercase, and if we have multiple words, we make each first letter of each additional word uppercase. So the F is lowercase and the N is uppercase. Now, because declaring a variable is a statement, we do end it with a semicolon character. With this statement, our first name variable is ready to use. But let's take a moment and talk about the variable identifier a bit more. You see, there's a few rules for identifiers, which I'm going to talk about now. First, they have to start with a letter or an underscore, or sometimes the @ symbol. But the @ symbol is a special case. That's not something you should be doing early on. Now, variables can also contain numbers, so you can put numbers inside variable names, and that's all fine. However, a variable cannot start with a number. It must start with a letter or an underscore. Variable names also must be unique in the same code block. So if I try to declare another variable with the same name, it's going to get a red underline and it's going to get upset. Now, some languages, people will use underscores between words or dashes between words. Well, dashes do not work in C# because it thinks you're subtracting first from name. Underscores can be used in the middle of words, but C# developers really don't often do that. Underscores usually go at the front of the variable name if they're going to go anywhere. Okay, well, that's enough about variable names for now. We have our first name variable declared. It's ready to store some string data. So next we have to prompt the user. Now, we know how to write text to the console, but let's make sure that the prompt and the user input are on the same line so that it looks nicer. So console.writeLine will write a line of text and it will automatically return to the next line. It has another method called write, which will not move the cursor to the next line. So we can say something like enter your name, space, and then in the console, it will leave the cursor right here so that you're typing on the same line as the prompt. This just looks nicer, so I like to do that. And the one thing I want you to notice when I talked about types having behavior and data, and the dot key being used to access a type's member, you can see when I hit dot, Visual Studio very helpfully shows me all of the data and behaviors that are available on the console type. And of course, there is the write and the writeLine methods. And if you click one of them and hover over it, you can see that it will give you some helpful text. So one of the nice things about typed languages that you don't get in some of the dynamic languages is you can get very detailed documentation in real time while you're writing code. And if that's not enough, you can always go to one of the types in the base class library, click on it, and press F1. And when you do that, it will open your browser window and it will take you to the C# documentation about that type. And this is where you can learn about its properties, methods, and events, all these data and behavior things that I was talking about. And it also gives you sample code. So this can be very helpful if you're doing your own research. Next, we have to get the data from the user and store it in our variable. We call this assignment. Whenever you want to store data in a variable, you use the assignment operator, which is fancy talk for the equal sign. On the left side goes the variable, and on the right side goes the data that you want to store in it. You might remember that I said that methods can receive data between their parentheses, but also sometimes they can return data. Well, the console.readLine method lets a user type into the console window, and when they hit the enter key, it returns whatever string they just typed in. We just need to tell our program to store this data in our variable like so. We'll say first name equal, so that assign first name what value. Whatever comes back from the next line read by the console. Now the data from console read line is always a string, as we can see from our tooltip here. So even if the user types in a number like 4, it's going to come out of the method as string 4. It's not going to come out as an actual number. That's important to know, because if you try to assign a value from the console read line to an integer, it's not going to work. It won't compile because a string is not compatible in types to an integer. But either way, in English, this line of code says, invoke the console's readline method and then assign the data it returns to the first name variable. And now that we have our data, printing it out is pretty straightforward since we already know how to use the WriteLine method. So we'll just copy this down here, and instead of saying hello world, we're going to say hello, and then we're going to put a plus, and we're going to put in our first name string variable. Because in C#, when you add two strings together, it concatenates them, which means smash it together. So let's go ahead and run our application. And what you'll see here is it says enter your name, and I'll go ahead and type my name, and it says hello Eric. So 4 lines of code. Declare a space to store it, prompt the user, store the result of what I typed in the console into the variable, and then print out a literal string plus whatever was put in the variable. So that wraps things up for this lesson. We learned a lot. We learned about the importance of types. We learned about the simple types that are built into the base class library. And then we hopped over to the code and we learned how to write comments, and specifically how to use comments to outline what you want to do in code. Again, as a beginner, you should do this no matter how simple the problem you are tackling is. It will really help you with your problem decomposition. And then using a comment outline, we made our first simple application. We learned how to declare a variable by using a type name and an identifier, and what the rules for creating those identifiers are in C#. And then with our outline, we were able to declare that variable. We introduced a new console method called readLine, and we were able to print out dynamic text. So now, instead of just hello world being static, we're able to change our output. It's all small steps, but these are the building blocks to building more complicated applications. So if you enjoyed this demo, be sure to like and subscribe and leave me some comments. The comments really help me with my motivation. I plan on continuing this series on approximately a weekly basis. And if you get impatient, head on over to skillfoundry.io. That's where all of my professional grade curriculum lives. It has videos, demos, written lectures, code samples, exercises, quizzes, everything you need to really jumpstart and accelerate your C# journey. There are over 200 learning hours published there as of today, and I'm adding more stuff on a monthly basis. Until next time, I'm Eric Wise from Skill Foundry. Happy coding.